Question 19 from the 2018 National 5 Physics paper is a question which asks us to solve problems involving volume, pressure and temperature for a fixed mass of gas. This is the gas laws and kinetic model topic. And so we have a sealed bicycle pump which contains a certain amount of air, 4 times 10 to the minus 5 cubic meters, and it's at a pressure of 1.2 times 10 to the 5 pascals. Just a little bit above atmospheric pressure, but the piston is pushed until the air gets much smaller in volume. The volume reduces to 0.8 times 10 to the minus 5, and you would expect that means that the air pressure in the pump is going to increase. So if the temperature stays constant, as we're told in the question here, we're now asked to find out what is the new pressure. So we need to pick one of the gas law formula. We've got pressure and volume. So let's use P1V1 equals P2V2. And so what we need to think about is what is the pressure and volume at the start. So I'm just going to do a little left-hand line up here. Pressure 1 is 1.2 times 10 to the 5, and volume 1 is 4.0 times 10 to the minus 5. Pressure 2, we're trying to find out. We don't know that. Volume 2, we do know, it's given in the question. The volume decreases to 0.8 times 10 to the minus 5. So let's plug these numbers into the formula and see if we can solve the problem. So pressure 1, 1.2 times 10 to the 5 times volume 1, 4.0 times 10 to the minus 5 is equal to pressure 2, P2 we don't know, times volume 2, which is 0.8 times 10 to the minus 5. Of course we want to solve for P2, so we need to divide the right hand side of the equation, this side here, by 0.8 times 10 to the minus 5 to get rid of 0.8 times 10 to the minus 5 from this side of the equation. So let's do that. 1.2 times 10 to the 5 times 4.0 times 10 to the minus 5 divided by 0.8 times 10 to the minus 5 will give us P2 as requested. So let's do that calculation, and my calculator says that P2 is equal to 600,000. In fact, we don't put commas in anymore because that just confuses people and makes it think that it might be a 1. So that's our value, 600,000 pascals, which is 6 times 10 to the 5 pascals. So the answer is E.